All right, so the most important thing to do before you even start looking at sample results is to understand the source and understand what the numbers mean in relation to the sample. So there's an excellent guidance document on DTSC's website. DTSC stands for Department of Toxic Substances Control. It's the state regulatory agency for hazardous waste. The DTSC oversees the CUPAs, or participating agencies, in implementing the hazardous waste program. So we look to them for guidance. And then, of course, US EPA, DTSC looks to US EPA for guidance. In California, we are a RCRA authorized state, meaning we are authorized to implement federal regulations. So this guidance document, I keep it handy, and I have all my inspectors keep it handy in their clipboard because it really helps you, and it helps facilities to understand what is a hazardous waste. And I don't know if I have the link on here, but if you go to DTSC's website, they have publications on the left. You go to Publications and Forms, click on that, and then you'll find this document. It's called Defining Hazardous Waste. It's a 6-page PDF document. And I would suggest everybody in this room keep that as a favorite or print it out and keep it handy in your clipboard if you're a CUPA inspector. And so we're going to go through this document. As we figure out how to interpret lab results, we're going to use this document as our guide. So the three main things in California in determining what is a hazardous waste, well, backing up one step, it's a different class, but first you have to determine it's a waste, okay, right? We all know that. So now we're past that step. Now we're determining if it's a hazardous waste. So the first thing is if it's a listed waste. And you can attend the Advanced Hazardous Waste Generator Inspection class if you want to know more about that. And then I'll jump down to used oil. In California, used oil is a hazardous waste by definition. There are some rules that would apply, and we'll talk about this towards the end about the contained in policy, and this is where you kind of get messed up a little bit on exclusions. But we're going to focus most of the time today on item number 2, the characteristics of hazardous waste, and determining what is a hazardous waste and interpreting those lab results or deciding what tests to run on a waste stream. And obviously, I know you can't read it, but I just want you to see that we have ignitability, corrosivity, reactivity, and toxicity. And this is the second page, I think, of that PDF document. And then each one has a link, and it goes to the methods that you would use to test for corrosivity or toxicity or all the other methods that you would be looking. Ignitability, what methods you would use. You click on that link, and it takes you to those methods. So this just one quick slide on remembering those 4 things. And everybody knows them? Raise your hand if you knew what the characteristics of hazardous waste were before you came here. Okay, good. Okay. Who calls it trick? Who uses ICRT? Oh, most people use trick. Okay. All right. So you say potato, I say potato, that kind of thing. Anyway, so trick is a good way to remember it. Toxicity, reactivity, ignitability, corrosivity. I use ICRT, and this is because my brain works this way, that because the D codes, the federal codes for listing of hazardous wastes are D001 is the federal code for ignitability, D002 is corrosivity, D003 is reactivity, and then D004 through 43 are wastes that would have toxic characteristics. It helps me keep it straight as the 1, 2, 3, and 4 and on. So that's the way I do it, but trick is a good way to remember also. So going through toxicity first. Toxicity is the big one, and I'm going to spend most of the time, the rest of the class, talking about toxicity. And then really quickly, we can get through picking methods for corrosivity, reactivity, and ignitability. That's fast. Toxicity takes a bunch of slides, okay? So there's And there used to be a class, and I don't know if we still have it, but Steve Koster did a class talking about the toxicity characteristic, and I stole some of his slides. Is he in here? No. Okay, good. Okay. So these are some great slides where he goes through and kind of explains how to identify waste as a toxic waste. Now, if you'll notice and you don't have the PDF in front of you right now, but these 8 ways to figure out if something's toxic are right in line with that DTSC guidance document. So the first is TCLP. We already talked about that. That's the federal method of determining if something's toxic. TTLC, totals and waste extraction test, is, and waste extraction test is the same as STLC. So that's the state terminology. And then we have acute oral toxicity, which usually it's oral rat data, oral rat, or sometimes you'll see oral rabbit, and you'll see the LD50, and if it kills off so much of the population, if it's considered toxic. Acute inhalation, acute aquatic toxicity, which is usually the definitive bioassay test to see if it kills off half of the fathead minnows. And then if it's a carcinogen. And then the last thing, of course, is knowledge or experience. Because you can use knowledge of process. You don't have to test your waste except under certain conditions. So how do you figure out what is the threshold for toxicity? What chart do you compare it to? What are the units? And what in the world is, how do you compare STLC, TTLC, and TCLP? Okay, you'll be able to answer these questions in just a few minutes. And then we have a quiz at the end, so make sure you're paying attention. All right. Okay, so the first, so that's just taking it out of that document, toxicity. You can look here. The characteristic of toxicity is defined as below, and then you can click on that link. 8 subsections. The first one is TCLP, or TCLP. So let's talk about that. So it identifies the waste that may leach into the environment, and it is reported as milligrams per liter. Who may require TCLP? I'm sorry? Landfills, very good. Landfill or the accepting facility for hazardous waste, they may be subject to permitting standards that are federal permitting standards, so they may need to have TCLP on the waste that you're sending to them. So haulers may say, before I can haul that, you're going to have to do a waste profile, and you're going to have to run the waste for TCLP. Okay, and then sometimes you might need it for evidence of return to compliance. And I get this a lot, is where a facility will show me TCLP results as their evidence of their waste determination. How many inspectors have seen that? No? Really? Okay. How many facilities use federal waste results for their waste determination? Okay, okay, which is okay. But one of the things as a CUPA inspector, if you see somebody who just has TCLP results as their waste determination, you want to ask some more questions about if they've ever realized what the California standards are. So there may be some metals that could exist in that waste stream that are subject to California and a hazardous waste in California, but they're not a hazardous waste nationwide. So that's not a federal hazardous waste, but it might be a California-only hazardous waste. Fluoride salt is a perfect example. That facility had TCLP results to show me, and they, part of their waste determination was TCLP results, but they hadn't fully assessed their fluoride in their waste. So that's something to keep in mind. So here's what it looks like, Table 1, and I know the numbers are small, but if you look up these sections in Title 22 or in 40 CFR, the federal regulations, then you will see something called Table 1. And Table 1 is the list of what the regulatory limit is for the wastes of concern, or concentrants of concern. Oh, we have a question? Okay, thank you. All right. Thank you.
Thank you. Do people still use that rule of thumb, the 10-20 rule of thumb?
Oh, the 20-time rule. Yes, I have a slide on that. Yes, yes. Any other questions? Yes, over here.
As far as the 8 procedures, the 8 procedures for identifying a toxic hazardous waste, the acute dermal toxicity and oral toxicity and inhalation toxicity are, I've asked this question before in other seminars, but is a generator, specifically a business or an industry, may be held to actually be required to do that? So if you're trying to prove a negative, in other words, by saying I went through all of the 8 characteristics, none of them came up as being hot. I mean, obviously I've done the T-clips, I've done the TTLC, the wet test, and the fish bioassay test. But these other 3 are basically something that you wouldn't expect to see unless you're in a research lab.
Right. Okay.
So
I'll repeat the question. It was kind of low. So he's asking if you would have to run acute oral, acute, those other tests besides, say, aquatic toxicity. And again, I'm going to get back to the main point of this whole thing is the hazardous waste generator is in charge. The generator makes that determination. So if you as the generator think that the data you have isn't sufficient, here's an example. Let's say on your MSDS for some product that you use, say MEK or something like that, it says on that the acute oral is, say, 25 milligrams per liter or something like that. And I'm just throwing this out. That's probably not right. But if you saw that on the MSDS for that solvent, then that would be something you would want to kind of think about when you're making that waste determination. We as a regulatory agency cannot expect you to run your waste for all 8 of those items. It's all of different ways to determine your toxicity. So you wouldn't have to run it. But if you as a generator feel concerned that, well, if this MSDS says that it's acute oral of this amount, then that might be something I need to be concerned about. Now, typically, and as a CUPA for sure, we don't run they're very expensive to run those kind of tests where you would collect. I mean, the aquatic toxicity is pretty simple. They have fish tanks in the lab, but running a toxicity test on rats and rabbits and that kind of thing, it's just, that's quite in depth. I mean, it can be done, but it's usually something that's not done routinely. But so you as the generator would make that determination. If you decide, no, I'm not going to worry about it, I just did the aquatic toxicity, I think I'm good. If there's not any element of doubt, then I don't see that a regulatory agency would say, oh, no, I'm going to run, acute oral rat on this or something like that, unless the MSDS shows that.
What if you have the case, as I do, of a waste that comes from, I'm an industrial laundry rather than an environmental laundry.
Okay. Industrial laundry, okay.
I've got, at one facility, I've got potentially 6,000 customer accounts with tens of thousands of MSDSs from whatever it is.
Okay.
Which is inconsistent on a day-to-day, basis.
So
establish what's defensible.
Right.
Defend the company that I work for.
Wow. Okay.
I don't think there's an easy answer. That's why.
Yeah, I don't know that. Just to repeat what the gentleman said, is that he works for an industrial laundry facility. They have thousands of customers with all different probably 10,000 MSDSs. So how can he have a defensible waste determination on the waste? I think that would be tough. You're definitely in a tough situation. One of the things that I suggest to facilities is to maybe consider some spot checking, just so that you have something that you're basing your determination on. That's the only thing I can think of to suggest to you, but you're definitely in a tough spot. Yeah. Okay. Patty, anything on, can you talk about the TCLP method and how you run that test?
Okay, TCLP test is supposed to mimic what happens if you take a solid material, you put it into a landfill, and it rains. What's going to leach out of your material and go down into the groundwater possibly? TCLP is the federal regulations, the federal idea of what rainwater is and what kind of ratio it is and what kind of time frame it is. California is different, but TCLP is a 1 to 20 ratio. That's where you were coming up with that 1 to 20, and it is correct. It's a 1 to 20 ratio. So for every gram of solid material, I'm using 20 mils of a buffer solution. Bless you. And so it's diluting that 20 times. It's a specific buffer solution. It's an acetic acid solution, and it's rotated end over end at that 1 to 20 ratio for 18 hours. After that 18 hours, everything settles, it's filtered and analyzed for, usually it's metals, but you can also do volatiles, semi-volatiles, there's tons of different tests you can do. There's different TCLP regulations that she was just showing you on the slide. So there's different tests we can do on that TCLP extract. But what we're doing is we're actually analyzing that water. We're not the solution, sorry. We're not back calculating it to the solid down here. Now the new sample is just that TCLP extract. So your results are going to be based on the volume, milligrams per liter. All the regulatory units or limits for TCLP are in milligrams per liter, so that's how we're going to report it to you. It's no longer milligrams per kilogram. This is just how much came out of the sample and went into the solution. It may not be 100%. You may have something that's just not very soluble, and so it's not going to go into solution. And so that way you're going to get your TCLP results then. And that's supposed to mimic what happens if it goes down into potentially into the groundwater.
Okay. All right, so here's some results, TCLP results. What is the analyte? Can you guys read it?
Chromium.
Chromium, very good. And what is the result? Non-detect, good. And what are the reporting units? Milligrams per liter, good. And at what level is the TCLP for chromium hazardous? Very good. And is this on this lab result, or did you just know that off the top of your head? It was on the previous slide, yeah, but it is here. If you see their TCLP limit. Some labs put the regulatory threshold on the report itself, which is kind of nice. Some don't, so you do have to look it up or keep that table handy in your clipboard or in your notebook for your facility. Okay, so I got to kind of pick up the pace here a little bit. Oh, and I already have these circled. Okay. Oh. All right, 20-time rule. This is right out of US EPA's FAQs, frequently asked questions. Is the 20-time rule acceptable? And I know it's a lot of small writing there, but it definitely is. So what a facility could do, or even a CUPA inspector, you could take any totals result and divide it by 20 as a rule of thumb to decide if you should run the T-clip. Okay? You could take any totals result. So what would be a totals result? TTLC, totals, total concentration result, and divide it by 20. And if that number exceeds the regulatory threshold, then you'd go, you know what, it's just hazardous. Or, you know, I want to test it to make sure, you know, you decide that way. But it is allowable as a method to make your waste determination. If you want to prove something is non-hazardous, though, then you do have to, you know, you may have to do, you might have to do some sampling. So let's just try it real quick. So these results for chromium, this is a totals result, so the units are milligrams per kilogram, and the results are 110. So let's divide 110 by 20. The answer is 5.5. And what's the regulatory threshold for T-clip? 5, right? So that's kind of borderline. 5.5 is by the 20-time rule. You might want to run the T-clip on that one, just to make sure. All right? And Patty already talked about it, but it's less aggressive. The federal test is less aggressive than the California test. It is sometimes not good for things like oils or certain types of solvents. You definitely need to apply knowledge in those cases. And obviously, if no information is available, then EPA says to handle it as a hazardous waste, or DTSC. Okay, quick little question here. So 4 of the 8 procedures used to identify waste as a toxic hazardous waste. Oh, that's kind of blocked, isn't it? Okay, let's see, what does it say?
It says acute.
Acute, okay, it's blocked, acute inhalation. Sorry about that. Okay. All right, good. Hey, you're still awake. Okay, number 1 is the correct answer. Very good. All right, one more here. Which of the below items were identified as hazardous waste in DTSC's defining hazardous waste guidance? The one I told you all to download. Okay, and the answer is, very good, all of the above. Excellent. Okay, and I'm going to go ahead and skip this one. We got to get going here. Okay, so interpreting totals and wet results, and this is, we're talking about California standards now. And so we've already talked about what TTLC stands for, total threshold limit concentration. That's the totals analysis. STLC is sort of similar to the federal test for TCLP. So they kind of go together, but one is a state test, one is a federal test. Here's something where you kind of get messed up a little bit, and this is something I was told early in my career, is that TTLC is the same as STLC when you're testing liquids. Well, I fell down on that one, and I messed up on a case where I just ran TTLC, I didn't run STLC, and then those sample results were disputed because they said, well, no, it's not STLC, those aren't STLC, it's TTLC. So I'll let Patty just talk a little bit about the filtration step that would occur in running the STLC.
An STLC test is based on just that soluble fraction, like I was talking about the TCLP, where we do that 1:20 ratio and let it settle, and then we filter it and just analyze that water, or the liquid portion of it. Same thing if you've already got a water sample to begin with, well, it's not going to have anything leach out of it and go to the landfill unless there's solids in it. If you've got this much solids and this much water in it, then the tests become more complicated, where we actually have to filter it, take this liquid, put it aside, take the solid, do the extraction on it, get the liquid off of that, and then recombine the two, because that's really what's going to happen when you put your sample in a landfill and it rains. The liquid's going to trickle right down, and the solid's going to slowly extract over time. So if you have a liquid sample to begin with, you should be comparing it to the STLC results and ask the lab for STLC, and that way we'll start with the filtering step too.
All right.
So your question there was, you had less than 0.05% solids, and the digestion method is the same, so it doesn't matter whether you run an STLC, TTLC?
You still should filter it just to prove your case, because otherwise someone can come back and tell you, well, how do you know for sure? Unless you did a % solids test. And we don't always do a % solids test unless someone asks us to. So you might have like a little gaping hole there, and you've got a lawyer, and he's going to go right into it.
Right, so in my example, the facility was this huge facility for years. Since 2000, we've been writing them up for not having PE certifications for their hazardous waste tank system. They had nitric HF tanks, acid, potassium hydroxide, and all this waste containing metals in the trenches of their facility. They had a big sump that was containing hazardous waste with heavy metals and corrosives. They were treating waste, lots of gallons every month. They're adjusting pH as well as removing the fluoride salts and other metals. And they weren't notifying to be under permit by rule, so they were unauthorized treatment. They'd been operating since 2000, and a lot of poor housekeeping issues too. Not a good environmental program. And so we, after years and years of warning them and trying to help them out, back in 2008, we decided to take enforcement. And we wrote a notice of violation for 27 violations, preparing the case for enforcement. They really cleaned up their act, but we did still need to do enforcement. We couldn't just not. So they hired attorneys and consultants to try to, they knew that they had done things wrong. It was pretty obvious. And they'd cleaned everything up, but they were really trying to just minimize their penalty vulnerability, because with 27 violations, hazardous waste violations of $25,000 per day since 2000, they were worried. So they were trying to find every single little thing to try to dispute our case, which makes sense. They had a good lawyer. They were doing their job. So because I had collected those liquid samples, and they were very clear, it looked like a glass of water, really, those samples, because we were trying to prove that, that they were treating something that was toxic as well as corrosive. And because that sample was clear, I was told, well, there's no solids in it, so you don't have to run STLC. So, and you know, I might be able to argue that point at some level by showing a picture of it. Well, yeah, it looked like a clear glass of water. There wasn't any solids in it. But it could be disputed because the results were TTLC, they weren't STLC. So it's just something to keep in mind. If you're going to do an enforcement case on a liquid and you're relying on those sample results, run STLC on it, just to be sure that you don't fall down the stairs like I did. It ended up, it was a good outcome for that facility. It was all good in the end. It worked out. So anyways, knowing those reporting units, usually you'll see TTLC, the totals is going to be milligrams per kilogram. Your liquids and your STLC values are going to be milligrams per liter. And that's kind of gives you a clue. So, yes?
So sometimes you'll get a TTLC results in milligrams per liter.
Sometimes you'll get a TTLC result in milligrams per liter, right? If you run TTLC on a liquid, right, Patty?
We can run total metals on liquids, and we report them in milligram per liter. But the report doesn't say STLC, it just says total recoverable metals.
Yeah, good question. Okay, so table 2 is what you compare STLC values to. Table 2 and table 3. And this is right out of Title 22. It's a good page to copy out of the regs and just keep in your clipboard or keep in your binders so you have the regulatory thresholds handy. And then the fine print, which I'm going to talk about in a minute. These are those footnotes that I mentioned. Okay. So steps to analyze for totals. You have your results here. Here's zinc. The sample result was 110,000 milligrams per kilogram. All right. So you got those results. Okay. Now you open up your book and you find table 2 or table 3. In this case, it's table 2. You look at those results, and you'll see that they exceed the regulatory threshold. You say, okay, I have a hazardous waste. And you're happy. See me running up the stairs? Okay, yay, good. We figured it all out. Sandy's class makes sense.